Yes, we are going to see about support vector machine. And Dr. T.S. Assistant Professor, Department of Computation Intelligence, SVM Institute of Science and Technology, Kattangalattur. And first we can see about what is support vector machine. Support vector machine is an unsupervised machine learning algorithm which is associated with learning algorithms and is used for classification and regression problems. And mainly what is the use of this support vector machine is you will be having many data. We have to segregate those data into two classes so that when new data point is available, we can place the new data point in correct place. Let us consider this is green. This is class 1 with the green colors and class 2 with the red colors. So when a new data comes, as we are segregated, we can place green here, red here, based upon the size or some other features which is available. Now, we said that it is used for regression and classification. Now, we should know about the difference between regression and classification, as both regression and classification are supervised machine learning algorithms or supervised machine learning mechanisms. And in regression, output variable must be a continuous nature or real value. In classification, output variable must be a discrete value. So when we are going for regressions, we will be having a input value x and output will be a continuous output variable. And the task of classification, input will be x and output will be y. Now we'll see about the different examples. We can say that when we are going to find a price, salary, age, etc. This is nothing but we are going for a prediction. So output will be a value. You will be getting some values for output. Age can be predicted. It can be 30, 20, 40 or anything. But when you are going for next level classification, here we are going to say as a Boolean value only, discrete output variable, such that what is the sex, male or female, whether it is possible or not, true or false. And when you are going for email, spam email, not spam email, everything will be a textual output. Here C is our output here, regression. What is the temperature tomorrow? Anyhow, we are going to give the value as a numerical value. This is a regression. Classification, will it be cold or hot tomorrow? Cold or hot? Both are textual value. That is the difference between regression and classification. Our SVM is used both in regression and classification. And there are two types of support vector machine. First one is linear support vector machine and non-linear support vector machine. You can clearly find the difference in the diagram itself. In linear SVM, it is a linear separable problem, which means that a data set is available and is classified into two classes with a single straight line. And the points nearer to this separate straight line is called a support vector. The point, red color point is available nearest to the margin. That is called as support vectors. And non-linear SVM, and it is a non-linear separable data, and which means that the data set cannot be classified using a straight line. What two mechanisms what we use? Unable to categorize into a problem similar to linear SVM. We need some other mechanism to categorize. So this is called as non-linear SVM. Process of support vector machines. It clearly says that we are using supervised binary classification. That is, we wish to categorize new unseen objects into two separate groups based on the properties. So what I can say as an example here is, we are going to have an input as dog and cat. We are going to classify dog separately, cat separately. So if you want to model that accurately to identify whether it is a cat or dog, the model should be created using SVM algorithm. First, we have to train our model with a lot of images of cat and dogs, and so that it can learn about the different features of cat and dogs, and then we can test with this strange creature. So support vector machine creates a decision boundary between these two data, and categorization is done based upon the input. So what we are going to have is, we can say as many examples. It can be of anything, spam or not spam. Based upon the situation, training is given. And as we have discussed, what we said, that is, we are going to find a new unseen object and we are going to place it in particular category. As I said, we are going to get the input as cat and dogs. When a new unseen object is received and training is done for dog and cat, so if that unseen object newcomer is checked, based upon the training, it will be placed in particular category. This is the process of support vector machine. And we are going to see two terms in support vector machine. One is hyperplane and another one is margin. And we are going to see about support vector machines. First, we have many scenarios which can be best hyperplane and what can be best margin. We can see one by one. What is the hyperplane? Hyperplane is nothing but a point which divides two data points. It will be called as hyperplane. And division can be done in such a manner that there should be equal space between both sides. Here, I have a equal space here. Let the space be 2 centimeter. I have the same space here. That will be 2 centimeter. I have equal space on both the sides. It will be called as a best margin. And the line which divides the 2 points will be called as hyperplane. And this will be called as a correct hyperplane. Or it can be said as hyperplane with the maximum margin can be said as optimal hyperplane, because our concept is to divide the points. When we say that hyperplane is maximum margin, then it will be called as optimal hyperplane. And how to find a right hyperplane? Now, how do we best segregate two classes within data? Our main thing what we have here is, here we have to check with the margin width. There should be equal space between the right and left. Or let us consider this class 1. Let us consider this class 2. There should be equal spaces from the hyperplane with the class 1 and class 2. When there's equal spaces, we say that that is right hyperplane. And when we are going to find a goal is to choose a hyperplane with a great possible margin between hyperplane and any point with the training set. So we will find the closest point with the hyperplane. And that point is taken and the distance is calculated with this point. And this distance is taken. Let the distance here is 2 centimeter. And the distance of class 1 is also calculated from the hyperplane to nearest point. When both the distances are same, we say this is correct hyperplane. and there will be any data, never any data point inside the margin. That is, I given a line here, margin is placed here. I should not have any data points within this margin. We have many scenarios. We can see each scenarios. Scenario 1, scenario 2, scenario 3, and goes on. And scenario 1, here we have figure. Here what I have done is, I have classified A, B, C. The points are classified. Now, our question is, which is the correct hyperplane? Here C. C classifies the star and round, but it is not properly classified because the red, some of the red comes upper and down. So C is not properly classified. So C cannot be said as a correct hyperplane. A, it classifies, but what happens is, it is not considering only stars, blue color stars. It's not considering red. So it cannot be said as a correct hyperplane. B is the hyperplane which divides exactly blue and red and equal halves. Here, while checking here, when I am putting a margin, I will be getting equal spaces between class 1 and class 2. And next, scenario 2. That is, we have hyperplanes A, B, C. Here also, we say this is the correct A, B, C. These are three hyperplanes what we have. Here, A has separated blue and red separately. B is a hyperplane which is separated, that is star and balls separately. But as per the concept, we cannot consider A and B because we said that right hyperplane is a plane in which we have an equal margin. But even A is considered, there is no margin for red. It's very closely available to red. But when you're considering B, there's no space from the hyperplane to the elements available here. So what we consider is, we consider C as a correct hyperplane because C is a hyperplane which divides equally. Margin is given equally. So C is considered as the correct hyperplane. Next, identifying the right hyperplane. When we are going for identifying the right hyperplane, here I have placed in this, our blue is available here. One of the blue is available here. Now consider A is available here, B is available here, but some of you may have selected the hyperplane B as it has higher margin compared to A. Compared to A, B has highest margin. So you may have select. You say that this proper reason will be there. But SVM selects hyperplane which classifies the classes accurately. Hence, hyperplane B has a classification error because we have a star available here, even though we say how many reasons for that. Margin is available, hyperplanes divide correctly, everything we can say. But there is an error because a star, blue color star is available here. So B cannot be considered correct. A separates all the blue color stars. Let it be class 1 and let it be class 2. It divides separately. So it can be considered the correct solution. Therefore, the right hyperplane is A. And next, we are having two classes. We are unable to segregate two classes using straight line. But as per the concept, what we say that is only one star is available. That is available at the margin, the last most point. Or outlier, it can be served as an outlier. So when we are separating the hyperplane, here 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 8 maximum is available. We are having a star at the end. This outlier can be ignored or it can be removed. And now we can have a hyperplane in this manner. So as majority of the star is available here, majority of the balls are available here. So this star is available in the outlier. So we can say SVM is robust to outlier and it can be divided in this manner. Now you can ask me a question, sir. Why can't we do this here? It cannot be done here because this star is not lying in the outlier. Its star is available in the middle. So no exact division can be done. But in this diagram, we have the star present in the outlier. We can ignore this star and place a hyperplane in the middle. And next, scenario 5. This is called as non-linear SVM. Unable to divide in any manner. We cannot consider outlier, we cannot consider any mechanism. So what we can do is, we can place a non-linear SVM. We can separate the round balls alone separately with the help of a circle. Straight line cannot be used for separating star and balls. A circle can be used to separate the interior balls and the exterior stars. And the next. This is the way how we have separated the stars. Two-class problem. Here, when we are going for this two-class problem, it is a linear separable problem. And you can ask me that, what is linear separability in artificial intelligence? Linear separability means there are two classes. And there will be a point, line or plane or hyperplane that splits the input features in such a way that all points of one class are in one half. All points are in one half. And the second class has another set of points. Now, we are going to say this. We have many examples for your SVM. But as we are saying about many examples of SVM, we say that SVM is very good. SVM can do all the functionalities. There are examples of bad decision boundaries also. Here, class 1 and class 2 are available. Here, what I am doing here, I am separating the equal halves, but the margin should be available equal on both the sides. So the hyperplane should be moved little upper. And next, this is also an example for a bad decision boundaries. Here also, I have class 1 and class 2. My hyperplane should be separated in this manner. This is an example of a bad decision boundary. SVM examples. And we are seeing about examples. Handwriting recognition is available. Intrusion detection is available. Face detection is available. Email classification is available. Now you may ask me a question that Okay, everything can be done with the help of logistic regression also. Why logistic regression is not good as SVM machine learning? Because when we are going to see about the concept, SVM works well with unstructured and semi-structured data like text and images, while logistic regression works with already identified independent variables. So the accuracy will be more. So when we are going to see, we have seen many scenarios. When we are seeing these many scenarios, we say that our SVM will be working good for all complex mechanism also. And SVM is full and full based upon geometrical properties of data, while logistic regression is based upon statistical approaches. And next, unlike a logistic regression, SVM are designed to generate more complex decisions. And here what we have in this as an advantage is what we can say. SVM is good in dealing with high dimensional data, works well on small data set. And the disadvantages of SVM are picking the right kernel and parameters are computationally intensive because we are going to work only with a small data set. And we say that it is very, very good in developing complex decisions provided that our data set should be very simple. And you may ask me a question that why SVM is the oldest mechanism, now more type of mechanisms available, why SVM is not in use right now? As data is increased, data set is more large, so SVM is not suitable for large data set. And SVM perform purely in imbalanced data set. And SVM is not good when there is too much noise in the data. So as data is increased right now, everything is not small. All the data increases even with the help of duplicate data. So we are unable to use SVM similar to the previous approaches. So this can be used as a good type of mechanism provided that it is a smallest data set. Yes, thank you.